In part A, we must determine the molality of zinc in this solid brass solution. We know that in general, molality is equal to the moles of solute divided by the kilograms of solvent. What we would want to do is figure out which component of the solution is considered the solute, and then which component is considered the solvent. Now, of course, the solute is the component that is present in lesser abundance. We were told that the solution is 20% zinc by mass, so zinc would be present in lesser abundance, and therefore it is our solute. And then the copper is 80% by mass, and so that would be present in greater abundance, making it the solvent. So, in other words, we can actually rewrite the molality equation a little bit more specifically here. We can say that it equals the moles of zinc, and then divide that by the kilograms of the copper. So really, our next step is to try to figure out the moles of zinc and the kilograms of copper. It's a little tricky, though, because the only information that is additionally given is the density. And so it's kind of hard to see how that connects to the moles and the kilograms. Well, we can begin to see that connection if we next assume that the volume of this solution is equal to 1 meter cubed. Now that's convenient because, think about it, if the density is 8,750 kilograms per meter cubed, and we assume a volume of 1 meter cubed, then the mass of our solution simply becomes 8,750 kilograms. So that's the mass of our brass solution. What we want to recall is the percent abundances. So once again, zinc is 20% and copper is 80%. So what we'll do is take this mass of the brass solution and we'll kind of split it up into two components. We've got the zinc component and then we have the copper component. And we're going to figure out the mass of each of those components. It's very easy to do that because the percentage given was a percentage by mass. So all we need to do is take 20%, which of course is 0.20 written in decimal form, and multiply that by 8,750 kilograms. And if we do that, that's going to give us the mass of the zinc component of this solution. And that turns out to be 1,750 kilograms of zinc. So far, so good. We'll do the same kind of calculation for the copper portion. We'll take 80% and multiply that by the 8,750 kilograms. And when we do that, we get 7,000 kilograms of copper. So this is getting us somewhere because we now have the mass of zinc as well as the mass of copper. The mass of copper is definitely what we need, right? In the formula, it's kilograms of copper. We've got that right here, so that's pretty cool. But what we really need to do next, as you can see, is figure out the moles of our solute, aka the moles of zinc. So that becomes our next challenge, is to get the moles of zinc. So we can write that down here. Moles zinc. Let's take the 1,750 kilograms of zinc and do some stoichiometric conversions here. So we're going to start by changing kilograms into grams. And of course, we all know that 1 kilogram of zinc would equal 1,000 grams of zinc. And if you see how we set this conversion up, you can see, of course, that the kilograms of zinc would cancel out once we multiply, leaving us so far with grams of zinc. But like we said, we want moles. So next we have to look up the molar mass. So we're going to need to take out a periodic table. Let me go grab one. Okay, and it turned out that the molar mass was 65.39 grams, and that's of zinc, and that would be equivalent to 1 mole of zinc. So that was directly from the periodic table of elements, and then once we multiply here, the grams of zinc will cancel out, and now we indeed have moles of zinc. So let's pick up our calculator and process this calculation, and when we do that, we can see that the moles of zinc is about, well, it's a rather large number. It's 26,762.5, roughly, and this would be moles of zinc. Okay, so let's think about what we've got. We've got the moles of zinc right here. That was the moles of our solute. And then we also had the kilograms of copper, which was the kilograms of solvent. And if we scroll back up to the equation, those were the two things that we needed to get the molality of the zinc. So here we go. Molality, which is symbolized by a lowercase m, would equal the moles of our solute, which was that 26,762.5 moles of zinc, and then divide that by the kilograms of solvent. That's 7,000 kilograms of copper. So let's go ahead and punch this into our calculators, and when we do that, we get a molality of approximately 3.82, and the symbol for that would be lowercase m. So that is the molality of zinc in this brass solution. And indeed, because that is for zinc, we might be smart here to just put the symbol for zinc right there. So there's your answer to part A. Let's take a look at part B next. And now we need the molarity of zinc in the solution. So let's grab the formula for molarity next. So here is the general formula for molarity. We have the moles of solute, and then that's going to be divided by the liters of solution. Now, let's recall the solute is zinc, so we can actually say that the molarity here is equal to the moles of zinc, and then divide that by the liters of the brass solution. So we'll just say liters of brass. Now this is kind of convenient because you'll recall we already know the moles of zinc. If we go back up and look through our information here, the moles of zinc was this value right here. So we're going to be kind of carrying that downward and plugging it in there. As far as the liters of solution are concerned, we go back up even further and we remember our assumption that we had a volume equal to 1 meter cubed. Now, perhaps we know that 1 meter cubed is equivalent to 1,000 liters. So we actually have the volume or the liters of our brass solution right here because of our earlier assumption that we had a volume of 1 meter cubed. So we can actually just start plugging everything in here, right? We got the moles of zinc, which was that crazy big number, 26,762.5 moles of zinc, and then divided by the 1,000 liters of brass solution that we assumed was present in this question. So we'll do this calculation, and when we do it, we can see that the molarity of zinc is about 26.8. 26.8. This will be symbolized by capital M for molarity, and that will be of zinc. This is the correct answer to part B. Thank you for taking the time to watch the video. If you're interested in making a small donation to my cause, I would greatly appreciate it, but please do not feel obligated. I always appreciate you taking the time to watch regardless.